All right, so we're starting by solving this equation for y. So specifically then, when it says solve for y, it means I want the final answer to have just a y left on one side, all by itself. Which means in this case, the stuff that's in the way of that I have to get rid of is the 2 and the plus r. Now, some people get thrown off by these because there's the letters. I can't just combine the numbers. That's okay. The operations are still the same. What do I want to get rid of first? Do I want to get rid of the multiplication first or get rid of the addition first? We get rid of the addition, yeah. Because remember, it's like undoing. You think of the normal order of operations, PEMDAS, they're going backwards through it when you undo an equation. So I'm undoing the addition first. In order to undo addition, I subtract. So I'm going to go ahead and do minus r on both sides, which gives me 2y equals BC minus r. A little side note here, a couple little things. This is expectations that I'm going to have in place for you this year as you solve equations. Notice I wrote the minus r under both sides. I need to show what I'm doing to the equation, and I need to show it to both sides of the equal sign. And notice I'm only doing one thing. Every now and then I'll see people try to do two things at once in an equation. Sometimes it works out, sometimes it doesn't. But the reason why I see it is because somebody's doing a problem. They're saying, I don't know why I'm getting it wrong. And it's because they're trying to do two things at once. And so if you only do one thing at a time, you're much more secure, much more solid with these. All right. The other thing I'll mention here is notice I line up my equal signs vertically. I want to do that whenever possible. It helps keep your work all that much more neat. Now, that being said, some of you are actually taught, like in junior high, to draw in that equal sign. Or not the equal sign, the line. That vertical line down the middle. And some of you will start by doing that. You'll draw this vertical line down your work. The idea of doing that is that it reminds you that there's a left side and a right side, and whatever you do to one side, you do to the other, and it also helps keep things lined up. It's a very useful tool when you're learning algebra because it reinforces these ideas. But it's kind of like training wheels, where it's a great useful tool while you're getting the hang of things. But at a certain point, you find that you're just doing that stuff anyway, and you don't need the line anymore. And so here in Algebra 2, I would expect you to be phasing that line out if you were taught that. So you no longer need that line going straight up and down the middle. All right. Back to solving our equation. I'm still trying to get y by itself. The 2 is in the way. Since it's 2 times y, I'm going to divide both sides by the 2. And so on the left side, that gives me y equals. On the right side, still lining up my equal signs. On the right side, how do we do BC minus r divided by 2? There's actually lots of ways you can do it. I think the simplest way is to just write BC minus r all over 2. I think that's the simplest way. But just so you're aware, there are other ways you could write that. Some people might write it as BC over 2 minus r over 2. That's fine. Some people might write 1/2 BC minus r. That would be fine. Or 1/2 BC minus 1/2 r. All of those are the same. They're all equivalent to each other. So I'm not requiring that you have to write it in this format or anything like that. It tends to be the tidiest, so it's where I tend to go. But any of those are equivalent. And so any of them will work. Continuing on our theme of equations with letters in them, technically called literal equations, please solve this one. Before we totally go through it, I do want to make sure you're heading in the right direction with this. We have a fraction equal to a fraction. Whenever you see that equal sign in between the fractions, that is what tells us to cross multiply. So if you weren't sure how to approach this one, start by cross multiplying. All right, so now we actually do the cross multiplication. Now, I'm going to go ahead and multiply the m times z first. Why? Because I'm arbitrarily choosing. It doesn't matter which one you do first. And so when I do m times z, that just gives me mz. If you write the time symbol in there, that's okay. Notice that when we cross multiply, that product is set equal to the other product, which in this case is going to be DH. That equal sign has to be there. Every now and then when I do cross multiplying, I'll see somebody who just turns it into a single fraction with no more equal sign. No. One way that you can remember that that's not it is because there's nothing we can do, mathematically speaking, that gets rid of an equal sign. And so since there's an equal sign in the original equation, there has to be one in our next step as well. All right? And plus the point of cross multiplying is to get rid of the fractions. All right, we just have one more step left. We're told that we want to solve this thing for h. And so to get the h by itself here, that means I got to get rid of the d. Since they are currently being multiplied, that tells me to divide both sides by the d. And so when we do that, I get an answer then of just mz over d equal to h. And that's what we're looking for. Side note here. Some of you, again, algebraically speaking, some of you have been trained where whatever you're solving for needs to be on the left-hand side. That's not really a deal. That's not something that we actually have to do. You can leave this as your final answer. You can leave the h on the right side. However, some of you still might really want the h on the left-hand side. And yes, you can do that. However, it is a separate algebraic step to flip the equation and move the left to the right and the right to the left. And so if you're going to be doing that, this is how I want your work to look. I do not want you just skipping this step and going straight from here to here, because you are then doing two steps at once. You are dividing and you are flipping it. And any time you do two things at once, you're prone to error, prone to mistakes. And we're trying to get consistency here. The biggest thing that I want you to get out of class and out of math in general is consistency in getting this precision down. All right? Next problem. Please solve this one. All right, now after the problems we were just doing, this one looks a lot more comfortable because we just have numbers and our one variable. No, since there's only one variable, I didn't have to tell you to solve for x, because obviously if we're going to solve it, it has to be for x. Okay, so it's much more comfortable. Fine, but there is still a mistake that is common on this, and I want to make sure we don't do it. The first thing I want to do is I want to get rid of this 9 here. Okay? What do I do to both sides to get rid of that 9? Do I add, subtract, multiply, or divide? Yes, very good. We subtract it. Now, the common mistake is some people think we need to add it because we see that, oh, there's subtraction between them. The opposite of subtraction is adding. But no, we are going to subtract it because the 9 itself is positive. And I'm trying to make that thing go away. In other words, add to 0. And so when we do that, we then have 15 equals, and now the other little detail, that minus is attached to the 5x. And so on this next step then, I'm left with equal to a negative 5x. And then we divide both sides by negative 5 to get to our final answer. It's knowing what to do with that negative that really is the key here, and making sure that we have that solid. So we get an answer of negative 3 equals x, and yes, you can leave the x on the right-hand side there. So having done all of those problems we've done so far, I think you're ready for this one, which looks big and complicated, but just trust your methods, trust what you already know, and let it take you to the end. You don't have to see the entire problem in your head before you start. Just go one step at a time and you'll get there. So as you take a look at this problem, there's actually multiple ways you could start. But I'm going to go through the most common way. I'll mention what the other one is after that, but the most common way that most people start is we look at this and we say, well, the first thing I want to do is simplify anything I can. And in this case, a great way to simplify is to get rid of the parentheses by distributing into 2. So I'm going to go ahead and do that first. I'm going to distribute into 2. That gives me 15AW equals, that becomes a 10t, that becomes a minus 6n. All right, I'm still trying to solve for n. always keep in mind which one you're solving for, because it tells me I'm trying to get rid of this and I'm trying to get rid of this. And that's just a matter of answering the question of which one do I get rid of first. And since I moved the 10t by subtracting it from both sides, that's the one I'm going to do first, because I want to get rid of any addition or subtraction first. And if you're wondering why do we subtract the 10t, that's why we did that previous problem, to kind of see why is it subtraction. Now, on that left side, notice I'm going to have a couple terms over there. I want to keep my equal sign lined up in the middle, so I plan ahead a little bit and I start writing further over. Neatness does usually require a bit of planning in order to have it come out looking good. All right, and then on the right hand side, I'm left with the negative 6n. One last step, I want to get n by itself still, so I divide both sides by the negative 6. And this probably feels a little bit familiar, where we're taking some big, ugly statement on one side, like this 15aw minus 10t, and dividing it by something. Forgot the negative on that 6. There we go. But just like the previous problem where we saw that happen, it works the same way. And so this would be your final answer. Now this answer can be written in multiple ways again. So just like that other problem we saw, yeah, there's lots of different ways you could format it, but this is certainly the most common. Now, that being said, at the start I said there was another way that you might have gone about doing this. Some of you might have started by actually dividing both sides by 2, because you have 2 times that whole side on the right. That would be fine. You can do that. You can divide both sides by 2 at the start. You're going to end up with some work that looks a little bit more complicated, but that's okay. The goal is not necessarily to find the most efficient route, it's just to find a route that will actually solve it. We can worry about more efficient routes later. Usually what happens as you find yourself doing more work than you have to, you become motivated to find a more efficient route. But the key is just getting there correctly. We've just been solving a bunch of equations. Now we're going to see how we can use the same techniques to solve inequalities. Go ahead and write this one down and see what you can make of it on your own first before we go through it together. Alright, so in order to solve this, certainly what makes this different from the previous equations we've just been solving is 2 different things. One, it's an inequality and not an equal sign. So we got that less than symbol. The other thing that makes it different is that there's 2 of them. Well, we can actually handle this fairly straightforward. First of all, the less than symbol works the same way as an equal sign. There's only one little detail that might be different that we'll take a look at in time. The other thing is the fact that this kind of creates 3 different pieces to our equation. We have one here, and one here. Well, when we solve an equation, what we do to one side we have to do to the other, right? With this kind of a setup, what we do to one side we have to do to all of the others. So basically I'm going to be doing the same thing to all 3 pieces. So, looking at the middle, I want to get the x by itself. The first thing I would do then is subtract the 1. If I'm going to subtract 1 from that, I have to subtract 1 from all of the sides. That is all 3 of the sides here. Basically anything that's separated by one of those less than symbols. And yes, it works the same way if they end up being greater thans or less than or equal to or whatever. Alright, when we do that, we end up with a negative 8 is less than negative 2x is less than 0. Alright, then after that, I'm still trying to get the x by itself, and so I want to get rid of that negative 2. So I'm going to divide by negative 2, and if I divide that middle by negative 2, that means I have to do that to all of the parts. So divide by negative 2 and divide by negative 2. And this is the answer I'm expecting that I would see on most people's papers. However, it's not right. But the reason why it's not right is because we just divided both sides, or all 3 sides, by a negative number. And this is the one rule we have to remember when solving an inequality. When we divide both sides by a negative number, we have to flip those inequality symbols around. So less than becomes greater than, or greater than would become less than, and so on. Now, if you remembered that rule about flipping the signs off the top of your head before I mentioned anything about it, you don't need to write this down because you remembered without kind of that little refresher. If you didn't, you could use the refresher. So write this down. It'll help reinforce it in your mind, even if now you kind of remember it. All right, we're now going to shift gears a little bit. Because as we're working on stuff so far this year, there's been some questions about functions. Some of us remember functions, some of us don't. So we're going to be looking and seeing what makes something a function. Now, as you take a look at these three graphs, can you tell which of those are functions, which ones aren't? If you do, then you're going to be in great shape. This is going to be easy for you. If not, we got to get some foundational pieces down. Because the thing about a function, what makes that word function special and unique, is that a function must always be predictable. In other words, for whatever x value I might name, we have to know what's going to happen at that x value. Now, for some of you, that means we need some definitions. That means notes. So, add this information, please, into your notes. Right, and so knowing that a function has to be predictable, that is, if I plug in a certain x, I know what's going to come out of the function, then this method of testing, if it's a function, kind of makes sense, because a vertical line held up against our graph is basically representing a certain x value. And if I hit it at more than one place, that means if it hits it once, I know it's predictable. I know what's going to happen at that point. If it hits it twice, that's a problem because I know that at that x, it could be either of those options. And a function has to be predictable. Now let's go back to our graphs and see how that shows up here. The first graph there, graph A, is that a function?
No.
No. It fails the vertical line test because there is some point on it where if I draw a vertical line, I hit the graph in more than one place. Now, that only has to happen once. In this case, it happens in lots of different places, but if it happens in even one place, it's not a function. So, this case, no, not a function. What about B? Do you think B is a function? This one takes a little bit longer to process. We pretty much have to check all the points. What about this one? Yep, that's okay. I only hit it once. This point, yes. If I keep going through at each of the points and checking a vertical line through those, each of those vertical lines only hits the graph once. So we're okay. But then the question comes up sometimes of, what about out here, let's say, where there is no graph? There's no points there. Is it okay for it to completely miss the graph entirely? Yes. It just can't hit it in more than one place. So 0 times is okay, once is okay. What about part C? Is part C a function? Yes, because it's a vertical line, not a horizontal line. And no matter where I draw that vertical line through, I'm only hitting the graph in one place. So yes, this one is also a function. Now with functions comes some special notation. You've been seeing this come up as well, and many of you are familiar with it and you remembered it, and some of you weren't, so we're bringing this back. That F parentheses X there, we read it as f of x. And so I read this then as f of 4. Okay, can you see on that graph what f of 4 equals? If you remember your function notation really well, you probably do. You probably have a number in your mind right now about what the answer is. If not, well, then we could use a refresher. Conveniently enough, I have some notes prepared on the topic. Please add this also to your notes. You'll be happy to know this is the last formal notes of the day. All right, so the high points here. Make sure that you know how to read this as f of x, because f of x is going to commonly come up and be used just like you've used y before. And when it comes to graphing, it works the same way as y. So whatever f of x equals, that's what y equals. That's your y coordinate. And so the reason why we use it is because it gives us some additional information. Whatever number I plug in here in the parentheses is your x value. Whatever f of x equals, that's like your y value. So I can get more detailed information from a single line. And so then it's saying when x is 1, then y is 5. And yes, it doesn't have to be f, and it doesn't have to be x, although those are the most common. For instance, like h of t is a very common equation that you use like in physics, where it's the height of an object at time t. Things like that. So having seen that, we now can go back to our same graph and figure out what would f of 4 be. When we see f of 4, what is 4? Is 4 the x or is 4 the y? It's the x. Because whatever is inside the parentheses, that's x. And hence, I go over to where x is 4, and I go up to my graph to see what the value is. It's asking what f is. That means it's the y value, so the answer there is 2. f of 4 is 2 on this particular graph. Okay, what would f of negative 2 be then? Take a moment, figure it out on your own. Yeah, f of negative 2 ends up being 6 because we go over here to negative 2, we follow that up to our graph, and we can see that that is up at 6, therefore f of negative 2 equals 6. All right, what if I phrase it this way? Find the value of x if f of x equals 1. So in this case, f of x equals 1. Remember, f of x is like y, right? And so it's like saying if y is 1, what's x? And so you go over to your graph. It's this point right here that we're hitting. And so, what is the x value? Looks to be 3. And so that would be our answer there, is that in this case, x equals 3. With that in mind, what would x be if f of x equals 6? Yeah, good. Negative 2 is one of them. But notice I say one of them because you'll notice that if I follow that line across at y equals 6, there's another one, right? Which is at 8, yes. So I'm looking to see any place where it hits the graph. And that's okay for that one to hit it in 2 places. Because remember, a function just means that for any x value, there's only one y. This is showing a y value that has 2 x's with it, and that ends up being okay.